Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, you will learn how to merge data between two different X-ray detectors. This tutorial assumes that you've already done tutorials on loading, averaging, and subtracting SAXS data. If you haven't done those tutorials, please do those now. This tutorial will use the tutorial data available on the RAW website. For this tutorial, we're going to use the data in the standards data folder. You can see it over here in the control panel in RAW. I'm going to enter that folder. This tutorial will use the wide-angle scattering data. So at the beamline where this data was collected, there are two X-ray detectors. One collects the small-angle scattering data, which is from about Q of 0.008 inverse angstroms to about 0.025 inverse angstroms. The wide-angle scattering detector, or wax detector, captures Q data out to about 0.75 and down to about 0.25. What we're going to do today is we're going to load up small-angle X-ray scattering data from the first detector, which we've already processed in a previous part of the tutorial, and then we're going to process the wide-angle scattering data and merge it with the small-angle scattering data to create one continuous scattering profile. So the first thing to do is we're going to load up the subtracted scattering profile data for the SAXS data. This is what we previously processed. We'll use the lysozyme data, which is the subtracted lys2 file here, s_a_lys2 as a .dat file. So I'm just going to load that in. Next, we're going to have to process the image files for the wide-angle scattering data. So I'm going to load up the wax CFG file, which is what we'll use for the wide-angle scattering, as so. So I'm going to expand out the name column here in the Files tab. What you'll notice is that for each collected data set, for example, for GI, here for the protein, there's two different sets of images. There's GI 0 to 9, and then there's these PIL3 images 0 to 9. At this beamline, this is how we differentiated between the small-angle scattering data, which is just the short name here, and the wide-angle scattering data, which had PIL3 in the file name. So what we're going to do then is we're going to process the lysozyme wide-angle scattering data. So this means we need to load in this lysozyme PIL3 data here, and then the lysozyme buffer PIL3 data, as such. So I'm going to hide the subtracted lysozyme profile. Actually, instead of hiding it, what I'm going to do is I'm going to move it to the bottom plot, because that's where the other subtracted profile will show up. To do this, right-click on the data and select Move to Bottom Plot. So now that we just have the wide-angle scattering data on the top plot, we can very clearly see where it is and what's going on. So what I'm going to do is average both the protein and the buffer and subtract them. You see we get a warning that one of the files is an outlier. I'm going to go ahead and average all files because we didn't see any outliers with the small-angle scattering data, so this is likely just a fluke. I'm going to remove the individual scattering profiles, and I'm going to subtract the buffer from the protein. So you can see here now in the bottom plot we have the subtracted SAXS data, which goes from very low Q out to a Q of about somewhere around 0.27, 0.28. Then we have the wide-angle data up here, which goes from about 0.21 out to 0.79. So in order to merge these data, we have to apply a scale factor to scale the wax data to SAXS data. In this case, we know the scale factor. It's actually just a geometric constraint based on the solid angle subtended by the pixels in each detector. And so what we're going to do is we're going to apply this known scale factor to the wax data, which is 0.000014. Once we've applied that scale factor, we can merge the two data sets. So what we're going to do is we're going to star the wax data, we're going to select the SAXS data, and then we're going to right-click, go to Other Operations, and select Merge. This created a merged profile on the top plot. I'm going to go ahead and hide the two unsubtracted data files that are on the top plot. And now you can see clearly this one merged data set. I'm going to move this down to the bottom plot so we can compare it to the subtracted scattering profiles, and I'm going to change the color here. Change the line color to red, for example. So what you can see now is that in the region where there's only one profile or the other profile, it is perfectly overlapping. It used just that single profile, and in the region where the profiles overlapped, it used the average between the two profiles, which you can see here. With that, that's the end of this tutorial. You now know how to merge data from two detectors.